outline of the talk is as follows. So I'll start with a brief introduction of what the voicing contrast is across languages. I'll present the motivation behind the study and the research questions. I'll describe the method and the 3 experiments with it, and then I'll end with a discussion. So most languages have a voicing contrast, almost 90% of them. So this means that they have voiceless pairs such as b, p, d, t, v, f, and z, s. But how this contrast is implemented, so how the vocal cords achieve this contrast, differs across languages. You have here 3 examples that are my own productions. So if my first language would be French, let's say, I would mark the contrast between ba and pa, looking at the first 2, the leftmost first 2. So for the ba, you can see between the red lines a voicing bar. So that means that the vocal cords are actually vibrating during the ba. For the pa, there is no vocal cord vibration. And after the release of the consonant, there is a very short lag before the vowel starts. If my language, my native language were another one, for example, a Germanic language, my contrast would be between the short lag, which would correspond to the ba, so there is no vocal cord vibration, and then to mark the contrast with the voiceless one, I would have some kind of aspiration, which means that after the release, you have that small, long lag of aspiration before the vowel starts. So depending on the languages, the contrast is marked differently. So languages that contrast the pre-voiced and the short lag consonants are called voicing languages, and the phonological feature that is taken into account is voice. Languages like this are the Romance languages, some Slavic languages, Japanese, or Hungarian. On the other hand, languages that mark the contrast using the short lag and the long lag consonants are called aspirating languages. So there is no vocal cord vibration because the vocal cords are spread. So the phonological feature that's used here is spread glottis. Languages like these are the Germanic languages. Mandarin is also an example, and some Turkic languages. There are, however, exceptions. So for example, Dutch, which is a Germanic language, is not an aspirating language, but a voicing language. And similar to Dutch, which is an odd one out inside the Germanic language family, European Portuguese has been found to be different. So European Portuguese, like most Romance languages, is typically described as a voicing language. So there is vibration of the vocal cords, but both small scale and large scale corpus studies have found that there's a high tendency to devoicing for both stops and fricatives. Also, a small-scale acoustic study showed that European Portuguese voicing profiles are more similar to Germanic languages than to Romance languages. And we also have tree-based classification studies that separate Portuguese from the other 4 main Romance languages. There's also a study from 2016 that says that Portuguese isn't...
Anisia, sorry for the interruption.
Yeah.
We are not sure if you have only one slide, the first slide, because we cannot see other slides so far.
Oh, I'm at my 5th slide now. So should I stop?
Okay. Well, you can jump to that slide maybe and continue.
I am at my 5th one.
Okay, we can see only slide number 1.
Oh, right. So should I stop sharing and reshare?
Maybe that would be helpful, yeah.
Sorry about that.
No problem.
Oh, no, this one. So do you see the 5th
yeah, now,
slide?
yeah. Can you jump to 6 quickly and then back maybe to, yeah, now it's working.
Yeah.
Perfect.
So
Thank
yeah,
you so
so
much.
this was so far. I'm sorry about that. Right. So I'll just continue from here. So it has been proposed that European Portuguese has a hybrid voicing system. So it's a voicing language when it comes to stops, but it's a aspirating language when it comes to fricatives. So then the question that arose was, does the implementation of the laryngeal contrast in European Portuguese show consistency within the Romance languages, or does it take a different path more similar to languages that are both genetically and geographically different? So there's a study from 2015 that investigated this particular issue by comparing voicing profiles in European Portuguese obstruents with Italian and German. And what they find is that the voicing probability during the stop drops after 30% of the obstruent in European Portuguese and German, but stays very close to 1 in Italian throughout the stop. So Italian is the third line of the graph. You can see that the voicing probability is close to 1 throughout the obstruent. So now we can refine our research question and ask, are voicing profiles in European Portuguese fricatives more similar to German than to Italian? This study is specifically about fricatives, but I do have a slide about stops as well. So to answer our research question, we analyzed a corpus of 114 hours of broadcast news speech from European Portuguese TV and radio shows. We had manual transcription, orthographic manual transcription for the whole corpus. And we did a forced alignment of these orthographic transcriptions using trained acoustic models and pronunciation dictionaries for Portuguese. We found similar amounts of v's and z's, so about 37,000 for each token. Portuguese also has a j, but since we're comparing this to Italian and German, we left it out because Italian has no j, and j appears only in loan words in German. So what we did is, to the original acoustic models, we put 2 additional acoustic models, 1 German and 1 Italian for the fricative phone models, in parallel with the original Portuguese model. And then once we align, the system can choose which variant it prefers. The 3 acoustic models, so the German, Portuguese, and Italian ones, are all trained on similar types of data, so broadcast news data, and on similar amounts, roughly 100 hours for each language. We use the same acoustic parameterization, which is cepstral and pitch features, and we use the same type of models, which are context, speaker, word position independent monophone models. And each phone model is a 3-state left to right continuous density HMM with Gaussian mixtures. So using this method, we can make the following predictions. If indeed the European Portuguese fricatives are more similar to German, we would expect the recognition system to choose the German phone models to a higher degree than the Italian one. If the opposite is, we have the opposite case, so European Portuguese behaves similar to Italian, we would expect the Italian acoustic model to be preferred. So this brings me to the first experiment. In this experiment, we had 3 parallel phone models for fricatives, the German, the Portuguese, and the Italian one. So the automatic speech recognition system could use either a German or Portuguese or an Italian V for a V that is in the data. So the results, unsurprisingly, Portuguese phone models, you win in most cases. There are, however, some cases where the German or the Italian models are preferred. And in these odd cases, the German is preferred to a higher degree. So if you look at the labial dental, German is preferred in 14.7% and Italian just in 1%. There is, however, difference based on place of articulation, so V versus Z. In the second experiment, we took out the Portuguese phone model for fricatives only, and we left the German and the Italian. So now Portuguese isn't an option. The automatic system needs to choose between either a German V or an Italian V. And these are the results. So for the V, in 89.5%, it chooses the German one. And for the Z, in 61.7%, it chooses the German again. So clearly, German is preferred to Italian. But again, similar to experiment 1, we have a difference based on place of articulation. In the third experiment, we changed the method slightly. So instead of running multiple acoustic models in parallel, we run them on a single language at a time. But we enrich the pronunciation dictionary with pronunciation variants. So for example, for the Portuguese word vai, which is go in the third person singular, the system could either choose the original voiced variant vai or the devoiced or voiceless variant phi. So, and we test this on German fricative phone models and on Italian fricative models separately. So just as a reminder, if we base our predictions on the Pape and Jesus 2015 study, where they find that the voicing probability drops after 30% of the obstruent in European Portuguese and German, so the first 2 lines of the graph, but stays very close to 1 for Italian, then we would expect that higher percentages of voiceless variants would be detected when using the Italian acoustic model. If this is not the case, we would have the inverse. And what we find is exactly this. So to describe the graph a little bit, so the white shades correspond to voiced variants. So if the vi was the vi is detected as a vi, it's in white. If it's detected as a phi, so the voiceless one is in gray. So what we can see here is that in both the v and the z cases, the voiceless variants are chosen to a much higher degree in Italian than they are in German. Again, there's a difference in place of articulation. So in conclusion, the first 2 experiments show that European Portuguese voicing profiles are closer to German than Italian. And when using a third experiment with a different method that relies on pronunciation variants instead of letting the system choose its preferred acoustic model, shows the same pattern. A distinction based on place of articulation is present in all 3 experiments. Now, we also tested this on stop consonants, so the B, the G series, and we find a completely different pattern. Only the B in European Portuguese patterns with the German, the D and the G are closer to Italian. So again, here, place of articulation plays an important role. But this discrepancy between the fricatives and the stops support the proposal of Ramsamy and Stricharczyk, which suggests that European Portuguese has a hybrid voicing system. So the stops are more like Romance languages and the fricatives are more like Germanic languages. So this result could be an indication of a sound change that's happening in European Portuguese, a shift from classic voicing systems known for Romance languages to more Germanic language patterns. And it is also a result that supports the use of automatic speech alignment system to test phonetic predictions like phonetic typology on large-scale corpora. I'll end with some future research avenues. So we would like to test this on German data and Italian data. We can also always use other acoustic phone models, so Spanish and English, for example. We would like to look at positional effects, so which variants were chosen in which phonological context. And we are currently running acoustic data analysis on the corpus. Thank you for your attention.
Thank you very much, Anisia, for the interesting presentation. Are there